So hydrochloric acid reacts with solid calcium carbonate, 2HCl aqueous, and calcium carbonate solid give you calcium chloride aqueous, water liquid, and carbon dioxide. Some students investigate the effect of rates of reaction of changing the temperature of hydrochloric acid. This method is use a measuring cylinder, pour in 50 cubic centimeters of hydrochloric acid, heat the acid to the required temperature, place the flask on a balance, add 10 grams of excess calcium. So an excess of calcium carbonate chips to the flask, time how long it takes for the mass to decrease by 1 gram. The experiment is repeated at different temperatures. The table shows the students' results. So you got different temperatures, same amount of acid. You got 10 grams, which is in excess, so the calcium carbonate's in excess, and you're measuring how long it takes for the mass to decrease by 1 gram. Okay, alright, so having a look at the questions then. So temperature of the acid, you can see temperature of the acid changing there, and time taken to lose 1 gram. So just by generally looking at this, we can see as you increase the temperature, the time taken decreases. On the grid opposite, draw a graph of the results. The axes and scales have been provided. Okay, we'll do that in a sec. One of the points is anomalous. Circle that point on your graph. Okay, right, so I've just clicked the table now so you can see what we're actually drawing. The axes have already been done for you, it's already been put on, so it should be quite straightforward to draw these. Okay, so acid temperature of 22, so 20, there's 30, so it's going up in 2, so there's 22 there. And 93 seconds, 22, 9. Right, so the next one is 35, 68, so 2 from the top of 70. Okay, 46, 65. 57, 40. 57, 40. 65, 33, 65. 1, 2, 3, 78, 26, so 78, 25, 26. That's a little bit further over, actually, to be more there. Okay, because it's 78, 79, 78, so it'll be just there. Okay. Right, so which one is the anomaly? So if you draw a line joining them up, the only one that doesn't fit perfectly is the third one we drew, 1, 2, 3, which is 46, 65, 40. Just check that point, 46, 55. But it's not far out really. Okay. So we circle our anomalous point in the graph. Now it's asking the student did not make an error in the reading using the stopwatch, suggest a possible cause of the error. So he read the stopwatch correctly. So a possible cause could maybe he didn't control the temperature properly, or indeed the size of the marble chips may have varied, as in if they were bigger, the marble chips, it would have reduced the rate of reaction. So the time taken to lose 1 gram at 30 degrees, you dot in a straight line if you can. Better with a ruler. Okay, so I'm going to go with 86. Okay, so that's 41. Okay, so that's 76 and 41. The rate of reaction can be found using the equation loss of mass divided by time taken to lose the mass. Use the equation and your results from B to find the rate of reaction at 30 degrees Celsius. So the 1 gram divided by 76 seconds equals 1 gram divided by 41 seconds equals so that's 0.013 grams per second, and the next one is 0.024 grams per second. So if you put them into your calculator, you'll be able to see the answer there. Okay, so how does the rate of reaction change when the temperature increases? As the temperature increases, the rate of reaction increases. Give one reason in terms of particle for this change in terms of particles and collisions. Okay, so looking at your collision theory, looking at temperature change, there's two reasons for the temperature change. So it is. Right, so I've put an example of an answer in here. So particles have more kinetic energy, so when they collide, they are more likely to have energy greater than the activation energy. So there'll be one mark there for the activation energy, and therefore more successful collisions. An increase in kinetic energy also means more frequent collisions, keyword there, so a higher proportion of successful collisions. Okay. I'm just thinking there we should put a clarifying sentence there. So we should put here. At higher temperatures, particles have more kinetic energy, so when they collide, and so on. We had the rest of it before. Okay, right. So just saying the reasoning for it.